Today we are going to start the new chapter, which is thermodynamics. Okay, so earlier we have completed that thermal properties of matter. Now here we are going to start this thermodynamics. So now what are we going to learn in the thermodynamics? See, so in this chapter we are going to have the relation between the or equivalence between the heat and work done. So whatever the relations we got so far, means whatever the relations we got, see, initially we have the different relations we have. Means when it comes to the work, you have work done equal to force into displacement, and heat Q equal to M into C into delta T or M into L. In the calorimetry we got that relations, right? So like that we got separate relations, right, in this work and heat. But how they are made to equal each other, in this chapter we are going to learn that one. How we are going to get that equivalence. Okay, and what are the topics we are going to discuss here? We are going to have the discussion about thermal equilibrium, okay, then what is that we are going to discuss. In this we have zeroth law of thermodynamics, and first law of thermodynamics, and second law of thermodynamics. So these are the things we are going to discuss in this chapter. Along with this, what is thermal energy, how the transfer of heat is possible, all these things we are going to discuss in this chapter. Okay, now first of all, what is thermodynamics? So we know that thermal means, the word thermo means or thermal means heat, right? So what about the dynamics? In motion, heat in motion. It is a study of the heat in motion. We are going to have this discussion in this chapter. Okay, so earlier there was this discussion about the heat. So what is this heat? Explanation was given of this. Earlier we have this heat, based on this. For this there was a theory which was not so correct, but it was there, which is known as calorific fluid. Heat is known as calorific fluid which is invisible, and self-repellent, and it is self-repellent. What is that? See, you consider any hot body. Let us say there is a bowl of water which is hot, means bowl of hot water is there. So according to that calorific fluid theory, so heat is an invisible fluid which is self-repellent, means it will try to move away from itself. Okay, now the self-repellent fluid, that is calorific fluid, it will always try to move away from itself. So initially it is that calorific fluid is there. When we consider this hot water here in a beaker, now what happens? This fluid will try to move away from itself, self-repellent, and it will not be visible. Whatever it is, the fluid is flowing away, that is not visible. So in such a way it was described earlier, right? But later there are other theories, but they got proved as false theories, means not correct actually. Understood? Now, so this was the old theory we have. Okay, now, so what about the heat and work equivalence? Means generally, so See how the heat is converted to work, or work how it is getting converted to heat. So those are the kind of discussions we are going to have. Okay, now so generally when we take mechanics, what are the things, parameters we are going to get? The force you will get, torque tau you will get, right? Force tau. Okay, these are the parameters which we will get the objects into motion. Because of the force you will get because of the torque also you will get that, right? So whenever you have any object, on that you apply a force, it will come to the motion, right? Whenever you have this object pivoted at a point and force is applied on that, it will have a torque, rotational motion. Understood? So now coming to this thermodynamics. Here we have, particularly we call it as system here. What is this? System is, this is the area or the space or the region which we are focusing on, that we call it as a system actually. Okay, let us suppose. So this is the region we are observing, and that focus on which we are focusing, that is known as system. And apart from this which we are observing, that remaining part is known as surrounding. Okay, we have the system and surrounding, and there is a line which is separating this system and surrounding. There is a line which is separating this system from surrounding, and that is known as boundary. So these are generally we will be using these terms in this one. So system. So generally majority of the times we will be using that word system. What is that? In thermodynamics we will say that system. System, it is also known as thermodynamic system. Okay, it is also known as thermodynamic system. What is that? It is the region or the space on which we are focusing upon. That is known as thermodynamic system. And the boundary separates the system from the surroundings. What is surroundings? Apart from the system, whichever is remaining, that is known as surroundings. Okay, system plus surrounding will be the whole universe. Understood? System plus surrounding will give us the whole universe. Understood? Right? Now, so in this thermodynamics, what are the parameters we have, by the way? In this system itself, in which region we are focusing upon, the parameters which we have, those are all having the macroscopic properties. Okay, macroscopic properties. What are those? Pressure, volume, temperature, mass, number of molecules or number of moles. So these are the things which we have in this thermodynamics. So what is the meaning of that macroscopic? See, when we are observing something from the majority, means when we are observing from the means not molecular level. See, we are observing all together, combined together, you are observing something. Suppose there is a box, in that there are particles we have, okay, or the particles or the molecules we have in this one. So these particles, these particles are having a certain pressure because they are placed in a box, and there is a specific volume for this container, and the temperature is also fixed in this one, and number of moles are there, the mass will be there for these things. So all these things are there. See, these are the things all combined together, we are getting these things, these properties, whatever the properties we got, all combined together at the larger scale level. What is the meaning of macroscopic? At the larger scale level, you are observing the things. When you observe the things in the larger scale level, that gives us the macroscopic view. Okay, but what about the molecular level, smaller level? Microscopic view. When you observe something in the smaller view, what is that? Microscopic view. Understood? So that is, where do we observe that one? Where do we learn that one? That we will learn in the kinetic theory of gases. Okay, there we will be observing the things in the microscopic level, which means at the molecular level you are going to observe that, we are going to observe that in the kinetic theory of gases. Okay, for this chapter thermodynamics, we will be observing the large scale view or a surface level concept. What is that? Heat and work done. These are the things, and the relation between these two, how we are making them make a relation between heat and the work done. Those things will be discussed in this chapter. And moreover, we have this thermal equilibrium, zeroth law, first law, second law. These are all the concepts we are going to discuss in this chapter as well. Understood? Right. Right. And there is another concept which we are going to discuss in this chapter along with this heat and work. Before this, we start learning these two. Already we have learned about the heat in the chapter thermal properties of matter already. So now in this chapter we are going to learn another concept which is internal energy. Okay. So this internal energy is also another concept which we are going to discuss in this chapter. Okay. Now let us start with this thermal equilibrium. Okay. Right.